here to talk about a engineering framework. It's called PaiMei. And quite literally, I finished these slides like 10 minutes ago during Hyperia's talk, so if there's any spelling errors or blatant mistakes, that's why. Like it not work. Alright. Just a quick slide about me. Exactly 1 year ago to date, I launched OpenRC here. And just out of curiosity, how many of you are repeat customers here? Not too terribly many, like 20%. So, anyhow, I'm currently employed by Tipping Point. I manage the security research team. We're a small group of people. We started about 6 months ago, and we're looking to expand. So if anybody's interested in doing like vuln dev type work, reverse engineering type work for a living, come stop by and talk to me afterwards. We've got a couple of things in the works, so you'll be hearing more about us in the coming months. And I just wanted to get this all out of the way as well. So quick thanks in advance. Cody Pierce and Cameron Hotchkiss, teammates of mine who, of course, have been supportive throughout everything. Peter Silverman is not here. He worked on one of the modules that I'll show you later for this framework. Eric Pereira, he helped me finish the slides. In fact, all these sexy graphics that you'll see, Eric built in also the last couple hours. And there's a whole group of beta testers who just helped crank out some issues and some feature contributions. So talk outline, we're going to go over the overview. What is PaiMei? What are the motivations for creation? What does it kind of break down into component-wise? I'll talk about command line scripts that are built on top of the framework and demo some of those. There's a console, GUI. I'll intro and demo some of the tools that's built on the GUI. And finally, we'll conclude with some in-house tools that we have that I'm not releasing as part of the public version. Some general bugs that I'm trying to work through, and some ideas for future development that other people might be interested in picking up and implementing on top of the framework. So first and foremost, the name. PaiMei is named after the Kill Bill 2 character, and actually I can't take credit for that creativity because Cameron came up with it. I originally wanted to name it something much not cooler, and it sounded like PaiMei, so he brought that out. It actually means white eyebrow, but it has nothing to do with this tool. Then there's the sweet doll. Somebody in this audience will be the proud owner of this fantastic lifelike replica of PaiMei. I haven't decided how I'm going to give it out yet, or if I'm willing to part with her or not, but we will see. So, what is PaiMei? It's essentially a Win32 reverse engineering framework, and it's written entirely in Python. You can think of it essentially as a reverse engineering Swiss Army knife. And it's been proven for a number of tasks to be very effective, like fuzzer assistance, code coverage, data flow tracking. And actually one of my beta testers used it to solve the F-Secure T206 reverse engineering challenge. And so the hopes and dreams for the tool set is that with community support and contributions, it can essentially become for RE tool development what Metasploit does for exploit development. Just providing like a common groundwork for people to build modular tools. So some motivations for development. I get sick of having to relearn all the different SDKs. When I'm in IDA plugin development mode, I can crank them out really fast, but then I'll go write something for OllyDebug, come back a month later, and I've completely forgotten all the different APIs. And it takes me like a while to get back in the swing of things. So I don't want to have to do that anymore. I'm sick of having to relearn these different SDKs. I also want to develop in a higher level language. While I can code in C, it's a lot easier to manage and build arbitrary data structures in a higher level language like Python. It's also less code, and it's less debugging of the actual tool. I don't want to spend half an hour tracking down the missing semicolon, I just want to be able to write it and go and focus on just the tool. And finally, I want to build data representation into the framework as opposed to an afterthought. So instead of having some Perl hack to take my text-based output and turn it into something pretty, I want that to be built in. Of course, this means translating it to the graph. So another motivation is the homogeneous environment. Making tools talk to one another is tedious. Writing an IDA plugin, then making that talk to OllyDebug, exporting that to MySQL, reading that into a text file, putting that out to a graph. So I want having to avoid that. I also don't want to have to switch between languages. Again, C, C++, switching between that and Python on any given day. And finally, I want a centralized tool creation. So, instead of the old school where you launch a debugger, run your plugin, save the output to disk, parse that with Perl, make that IDC, IDC into IDA, IDA into GraphViz, I want to avoid that whole, ghetto-ness of having to transfer things back and forth. So the core components of PaiMei. The biggest portion is a component called PaiDebug. It's a pure Python Win32 debugger abstraction class. And we'll get into the details of all these later. Another core component is pgraph. It's a abstraction library for representing graphs as nodes, edges, and clusters. And PyDef, which is built on top of pgraph, it represents binaries as a collection of functions, basic blocks, and instructions. Kind of similar to PyREml that Arrow developed, I don't know, maybe 2 years ago, whatever it was. The extended components are utilities, which is a set of abstraction classes for accomplishing various tasks that you don't want to have to redo every time you build a new tool. There's a pluggable WX-Python GUI, and finally there's scripts, the scripts that you build on top of this script. So diving into the first major core component, PaiDebug. PaiDebug exposes all the expected functionality and then some of a Windows debugger. In fact, I'm fairly confident that at this point it can do more than what OllyDebug can do as a scripted debugger. So you have all sorts of things, like your process, module, and thread enumeration. Here are the example API that are exposed to do that, really standard issue stuff. You have hardware, software, and memory breakpoints. OllyDebug supports, of course, hardware and software breakpoints, and it supports one memory breakpoint. PaiDebug supports unlimited memory breakpoints. You can, of course, do reading, writing, allocating, and smart dereferencing of memory. So for people who use OllyDebug, if you've noticed, anytime you see an address, if that address points to a string, OllyDebug will read that string and display it for you. So I call that smart dereferencing, and that's built into the PaiDebug library. Some things that you won't see in other debuggers, it has memory snapshot and restore capabilities. And essentially what this does is it will step through all the memory blocks within the target process. Anything that's marked as writable and not part of the image, it'll make a copy of it. So especially on rudimentary programs, I can take a snapshot of memory, execute forward, and then rewind and be essentially back at where I started from. Of course, neglecting all like handle changes and all that jazz. It also, of course, saves and restores all the thread context. So for something more complicated like Office or Internet Explorer, that's not going to be useful for you. But if you are looking at like a small subset of functions and you want to run something and then rewind a couple functions back, you can do it with this. So I've also seen recently, I forget what it's called now, undo DBG. It's built on top of GDB, and it essentially allows you to use GDB to step backwards in the debugger. And I think, I haven't tried doing it yet, but I think that would be possible using this memory snapshot restore. We'll see. It does stack and SDH unwinding, exception and event handling, so you can set a callback for anything. You can say, set callback, breakpoint, here's a function I want you to run if a breakpoint's hit. Set callback, access violation, call this function if an access violation is hit. And it does disassembly, which is built on libdasm. And the one thing it added around that is disassemble around. So if you give it an address, it'll grab a window of bytes up and down, and then it'll rewind up enough to start disassembling forward and hopefully align itself correctly to give you, for example, the 5 instructions above and the 5 instructions below the address that you specified. Then there's utility functions like MDN manipulation, resolving functions, hex dump, converting to binary to decimal, and there's a whole slew of other ones that are all really well documented. I'll show you the documentation later in the slideshow. So here's like an example of PaiDebug. It shows you how this abstracted interface allows for painless development. And all we're doing is we're importing PaiDebug and some definitions to the top. We define a function, handle a breakpoint, it accepts a PaiDebug instance. At the end of that function, you'll see I'm instantiating a new debugger. I'm setting a callback for exception breakpoints. I can actually show this in my mouse. I attach to some process, resolve, winsock, receive, set a breakpoint on it, run. So whenever receive is hit, assuming that it's not the first Windows event-driven breakpoint, I'll print that receive was hit, where it was called from, and continue executing. So in roughly less than 15 lines of code, you can run the script and see every single time receive is called. Of course, this is a very simple, contrived example, but you can see kind of like the power and benefit of being able to easily write a debugger in Python. So like random ID implementation. When that F-Secure T206 challenge came out, I would like to solve it, but I'm lazy. As it turns out, it was like some virtual machine. I don't want to sit there and reverse engineer some challenge that's going to take me 8 hours when there's other work to be done. So I thought, well, I might be able to use the snapshot restore to brute force this thing. So I opened the binary IDA, I found the password read and process exit points. And I actually probably should have done a demo on this. Maybe afterwards I can show some people who are interested. So using a PaiMei script, I set breakpoints on both. The first time the password is read, I snapshot process memory. Then when the exit is reached, I restore. When I restore, I read the buffer address of that read password off the stack, I mutate it, and I continue. And so this gets it pretty fast, because there's no startup, shutdown, overhead. It gets a pretty fast password per second cycle. And I let that run for a day, and it went through a whole bunch of passwords. It didn't get it, but it would have eventually. So another core component is pgraph. Pgraph exposes much of what you would expect for functionality for an abstracted graph layer. So you have node and edge management. Add, delete edge, add node, delete node. You have node and edge searching. So find node, that'll let you take any attribute you want. So for example, if I extend from the node class and create a function as a node, I can say find node, address, and what the value is, and it supports it transparently. I can do edges from and edges to see all the, for example, in our case, cross references to and from, or for your graph, just for pure graph purposes, your integrate and outintegrate. The graph manipulation is really interesting. So you can do arbitrary things like take two graphs and combine them. You can subtract one graph from another. You can draw a graph up from a specific node or down from a specific node. You can do the intersection of two graphs. You can do a graph proximity. So tell me all the nodes that are 3 levels above this one and 2 levels below it. And of course, you can combine these calls together to build arbitrary graph slices from your overall graph. And then there's graph rendering. So this is also built in. You never have to worry about any of these things. At any point, you can render a graph in GraphViz, GML, or UDraw. And we'll see later how these things are beneficial. So why do we need this library in the first place? Well, that's because of this general background information, which, for those of you who know it, I apologize. So it's because disassembled binaries can be represented as a graph. The functions are nodes, and the intramodular calls are represented as edges. This is known as a call graph. So here's a very simple, contrived example. I have a bunch of subroutines, and the edges between them to represent, who calls what. You can also represent a function as a graph. And the way you do that is basic blocks are the nodes, and the branches between the basic blocks are the edges. So on the left-hand side, in that contiguous block, you see, sub underscore 0010. We have a couple of instructions. The ... represents any non-branching instruction. Then we have a branch. We have a few more instructions, some more non-branching instructions, some more instructions, yada yada. So what happens is this first part, all the way down to the first branch, becomes a basic block. And then that jump, 0, the true branch, starts a new basic block, and the false branch starts a new basic block. So we have left now, we have 1, 2. And then this last edge is an implicit edge that connects these two blocks together. So this is also known as a control flow graph or a CFG. Is there any questions at all about how a binary can be represented as a graph? No? Great. So PaiMei extends from pgraph to represent binary as a graph of graphs. And what that means is that the module is a graph of functions, and each function is a graph of the basic blocks. So overall, we have this graph of graphs. And these PaiMei files are propagated by an Python script called PaiMei. This is important. I'll show you in a second. The database is serialized to a zlib compressed pedophile, and yes, we can pronounce it pedophile. In hindsight, it was a poor name choice. And this pedophile can later be loaded independent of either. So once you do this analysis once, the idea is, you're finished with either. You don't have to deal with it anymore. And of course, another benefit is, currently, I propagate this structure with an Python script, but eventually, there'll be other ways of doing it. I know, for example, Arrow is working on disassembler that, maybe over the course of the summer he'll release, and as soon as that comes out, I'll run it and put it together so that I no longer require IDA to generate these files. And of course, since this expands or inherits from the graphing library, all the aforementioned graph functionality is available for use. So just very, very quick demo to show how a pedophile is made. Throughout all my examples, I'm just going to use WinMine because it's small and fast and easy. Just like a pedophile would want. She said it out loud. So I'm in IDA. I just I'll give everybody 10 seconds to recover. I'm in IDA. I just hit the IDA Python hotkey, whatever it is, Alt-9 to launch a script, and I'm going to go run Pedram. And it prompts me with some dialog box that says, what kind of analysis do you want? Full, function only, or basic block levels? And I'll just do full. And it says, do you want to propagate nodes and edges for API calls? So in other words, by default, you have the option of choosing whether or not external API calls a node is generated for them within your database. So we're going to say yes. And the last thing is it supports RPC enumeration, but we don't need that because there is none here, so we'll just leave that. And I'll ask you for a file, you save it, and you're done. I can start scanning. This one's pretty fast, whereas it's a disk. For larger ones, I have some stats somewhere, but it takes roughly as long as it takes IDA to analyze a binary. Maybe a little bit less than that is how long it takes the IDA file to be generated. So we'll just move this way now. So, following the previous example, what can you do with this? Again, the abstracted interface allows for painless development. So I import the PETA library, I'm loading a module, and then I'm saying, okay, right off the bat, the modules are graphed, so render it as you draw, and write it to that file. And boom, it's done. It'll draw this graph, and I'll show you all these graphs later, example ones. Then I'm going to say, okay, now step through every function. So for function in module, that functions have values. If the function name is whatever, step through each basic block. Print the instructions in that basic block. And then later I say, okay, graph that function on its own. So, very, very simple stuff, very easy interface, and very small code. Continuing on, if the function starts at whatever deadbeat, I'm going to make another proximity graph. I want to look 3 up and 3 down, and I want to graph that as well. So that's going to give you the graph of the function and the functions that are related to it, 3 levels up, 3 levels down. So together, PyDA and PyDebug offer a powerful combination for building robotic tools. So consider, for example, those of you who know about it, how easy it is to rebuild process docker on this. I can just run a PETA analysis. I can say, okay, for every function in module, for every basic blocking function, PyDebug a set breakpoint. Register a handler, every time it's hit, save the address. Of course, it's a oversimplified approach to it, but that is the basis of it. So a real-world example for PETA. I have this problem. I need to locate all functions within the binary, but at some point open the file, and I want to display the execution path from the entry point of that function to the call of interest. So in other words, for every function in this binary, tell me which ones open the file and how to get to it. So it's easy. I step through every function in the module, and I create a down graph for that function. And then I look through all the nodes in that down graph, and I'm doing a regular expression search for create or open file. And then, if there is any matches for that, I create an up graph from there. I combine that with the intersection of the first one, and now I have the whole function. I do a down graph from there. If there's a call to create or open file, I do an up graph from that one. The intersection of those two is the possible paths from the entry point to that target API. And then I write it as a GML graph to disk. So very simple and very effective. I can run this over a whole module. I have a bunch of alpha graphs. I can look at it and answer my question. So the utilities, which is an extended part of the framework. They're just classes for further abstraction, just to make less code and life easier. We'll go through each one. There's a code coverage utility. This is just a simple class. It supports persistent storage in MySQL or a serialized file. And what is that? Yes. You can use this class to keep track of where you're at. So examples, process start uses this. Or if you're writing a fuzzer and you want to use code coverage capabilities, you can use this code coverage utility and very easily keep track of the basic blocks that you've hit as you've been fuzzing and monitoring. Crash binning is something that's really interesting. It's a simple container for categorizing and storing, crashes or access violations, different exceptions. So stored crashes are organized in bins by exception address. So this is a version that you get. You can use this crash binning class. It's very easy. Every time, let's say, for example, file fuzzing tool, every time a crash occurs, instead of just saying that it occurred, you can say, okay, it did occur. It occurred at this address. So at the end of this run, instead of having an output that says, we caused 250 exceptions, we can say we caused, actually that's the bottom right there, we caused 248 crashes at X and 2 crashes at Y. The in-house version of this class goes one step further and actually categorizes on path as well. So we bin it by exception address, and then we look at the stack on Y, and we say, okay, 5 test cases caused a crash at this address. 3 of them took this vector, 2 of them took this other vector. There's also a crash synopsis member routine. It can be used to generate really detailed crash reports with just one line of Python. So it tells you like the offending thread ID, exception address, where it happened, disassembly, unwinding, all that kind of jazz. Notice myself. So Excel file format exploit bug. So Cody found this Excel file format bug, and there was this huge debate on whether or not it was exploitable. And I mean, he got me hooked on like a Friday, so I spent the whole weekend reverse engineering Excel, trying to figure out whether or not this thing is exploitable. And it was a lot of work, and I really got sick of it. So I said, forget this. Like, I'll just take PyDebug. I'll take the portions that I do know, like these bytes influence some code flow. These bytes influence some code flow. And I literally wrote an exploit buzzer. I used crash binning, I used PyDebug, and I just randomly generated the bytes that I knew would cause some influence on the execution path, and I let it run overnight. The next day I can come back and I say, okay, there's 5 crash points. These are the vectors, look at each one, none of them are exploitable, that's it, case closed. No need to further spend time with unnecessary. Process Docker utility. This is an abstract interface to Process Docker. It's currently only used by the GUI module, which I'll show you. But because it's abstracted, you can build a command line interface really easily. And they handle all the basics, rebasing of breakpoints, whenever a library is loaded, setting breakpoints in that, recording whether or not you want context data, recording that, monitoring for access violations, exporting to MySQL, all the basic stuff. The udraw graph connector is one that's really interesting. It's a Python interface to udraw, which, if anybody doesn't know, is a really badass graphing library. And that's what I'm going to demo on this other screen later in the presentation. And so much of the API is still unwrapped. I kind of add it as I go along and as I need it. But what I do have is you can draw graphs, you can make a new one or update the current one. You can move the graph, so focus a node, improve the layout, change the scale, open a survey view. You can modify the graph, change element colors, change the window, background status, title. And you can register callbacks. And callbacks for udraw are, so if a node is clicked or double-clicked or right-clicked, I want to know about it, and here's a function to take care of it. So how this whole thing ties together, if that is reasonable for people. The blue is just this notion of PaiMei, the red are the core components, and then you can see, PyDa is a module function-based block instruction. You can see how it inherits from node, graph, and edge. You can see the utilities, and then the green is where your scripts, my console, my script, that's where they all live on top of this framework. So getting into some of the example command line scripts, one thing I wrote, which is very, very useful, is DPC, debugging procedure call. And essentially what it allows you to do is call any arbitrary function within your target. And it's implemented using a pretty simple process. So say, for example, there's some procedure in some file that we're looking at. Let's say it was in line. And I want to call it with 2 arguments, a string, Pedram, and number 25. So what DPC does is it's going to allocate space for new instructions inside the targeted process. Then it's going to reverse the argument list, so the 25 Pedram. It's going to push the numeric arguments directly. So it'll write a push instruction with the actual numeric value into this allocated space. For strings, it'll have to allocate memory for the string, grab the address, and push the address. Then it does the call, and it writes an int3. And the reason why it does that is the way we're doing this is, as soon as we attach, we have control of the process. We're in a breakpoint handler. So I'm going to make all these changes, and then when we actually do the call, afterwards I'm going to catch the int3 again and give you another prompt, and you'll be up and running. So let's see. All right, so usage. Once you're attached, you're going to command prompts. Any Python statement is valid. So if you want to, create random little tiny scripts or constructs, you can. There's a debug variable which references the current PyDebug instance. There's convenient trackers for memory allocation. This is assigned this global variable. So if you want to save some content between calls to DPC, you assign it to Bob. And it also supports fast calls, so I can assign registers as well. And it took me less than 30 minutes to write the first version of this tool. And before you guys get bored out of your mind, let me show you the easy example. So here goes Squidwin. Oh, that's terrible. Let's see if we put it this way. That's also terrible. Fix this. There we go. That'll work, yes. And let's just run. We'll just run Minesweeper since that's the name of the thing. There, you can see it. So I'm going to attach it to VinMod. And as soon as I do, I get this command prompt. So I can do anything here, like just to show that it is a Python interpreter. I can be like, like that will work. And so now I want to call, let's, for the sake of demonstration, I'll call message box. So first I need to resolve it. So I'll do mbox equals, dbg is my PyBug instance. Got func resolve. So using 32 and one message box A. That looks right. And then we can just call it. So dbc, I'm going to call it mbox. Parameters are number, text, number, and it is, here it is, it's on my other screen. So I'll move it over, and you'll see it is from Minesweeper, because it's got its Minesweeper icon, and it's the function that I ran. So this is, a simple example to prove that it works. And then whenever I'm done, you see it tells me the return value. I can just show all the allocations. Those are the ones that were generated in order to actually make the call. You can allocate your own blocks of memory. And then whenever I'm done, I can detach from it, and Minesweeper is just fine. It's still running. And so I can call any arbitrary function within this process. I don't know how we got there. Was it actually going behind the scenes? Yeah. So people have already seen that problem? That's unfortunate. Anyway, so here's like an example. We were reversing something, and there was this function. It was heavily math-based. It would have taken me a long time to figure out, what it actually did. So instead, I'm like, well, let me just reforce it out. Like, I will give it some. I knew it took a number and a return a number. So I'll give it a number. I'll look at the return address. I'll just write a few of them down and try and guess what it is. So whoever can get this first. You all saw this already? Did this already scroll on the screen or no? No? Awesome. So the first one, if I give any number between 25 and 29, it returns 29, and the range of my inputs was 6. So I'll just start going through this, and whoever can figure out what this function does first.
Duh.
It's what?
Duh.
No. Who said that first? All the way in the back? Yeah, it gives you the next prime. And if you thought that was dirty, there was another one that was giving you harmonic primes. So that was going to be much more difficult to figure out just by looking at it. And in fact, you get the doll. So you can come claim the doll afterwards. So that's what that is. It's just if you give it a number, it gives you the next prime above from that. So you can see, there's great benefit to this because it took me 2 minutes to figure out that the argument was a number, and 5 minutes to just run this and figure out what the function was. Never have to actually look at the code behind it to see how it works. So here's another example. This one takes 3 arguments and then a return. So here's the first one. Anybody?
String compare.
Huh?
String compare.
Yeah, it's string. So again, there's no symbolic information, and looking at the code, it would have been difficult to step through and figure it out. But again, it takes 2 minutes. I knew it was 2 strings and a number. Just threw some stuff out there, figured out what it was real quick. And that was, I already gave you the live demo for that. So another tool that is built on top of the platform is an Olibug connector. For the most part, PaiMei is for non-interactive functionality. This tool is a 2-part tool that adds live graphing functionality to Olibug. Part 1 is a receiver. It's a socket server, listening for connections from Olibug. It receives the module name, base address, and offset from a small plugin I wrote. The socket connects to UDraw, which is that thing over there, and it loads the specified pedophile and generates the graph. So part 2 is the actual plugin. It registers 3 hotkeys. One is step into and transmit current location. One is step over and transmit. The other one is just transmit. So we'll just quickly over that one. It's over there. Oops. All right. So so this is attached to Minesweeper. Minesweeper is somewhere. It hasn't started up yet. And that's another laptop. And actually, so all the UDraw stuff is oversized. So originally the demo was going to be using dual monitor, but since nobody has a DVI adapter for me, I had to fall back on a second laptop. And actually, this is the first time I've tried it over socket. It does work. So first time you hit one of the keys, it's going to ask you for the actual server address. Which, oh, you know. All right, bear with me for 1 second. One second. The actual server is hard-coded to connect locally, and I need to give it this IP address. So this IP address is 10.3.100. Here's the server, it's listening, it's hard for you to see. Some of the local hosts. Alright, so you saw it work. So that's on a different machine. So we're at the top of a function. So when you're at the top of a function and send the location, it gives you a call graph. When you're inside a function, so if I step forward 1, then it's going to give me the control flow graph. And you'll see it'll update in real time. So I can step through, I'll step over some value. In fact, hard for this to see. So you can see it going through, and it's in synchronous. Whoa, now. Screen saver. So it's synchronized. Like, as I step in OllyDebug, it's going to step over there. It highlights your current. It highlights your current node in orange and where you were in blue. So that is the OllyDebug. And again, like this thing took me like 20 minutes to write because all this graphing and connection stuff is free. It's all built in really easily. So another tool that was built, ProcPeek. It's a 2-part tool designed to find low-hanging fruit vulnerabilities, which, believe it or not, is quite a thing. So the first half of the tool is a static reconnaissance base. It's called ProcPeek REcon. And the second half of it is a runtime analysis. That's the part that builds on top of PaiMei. The general philosophy is, with minimal setup, I want to generate a list of locations that could be interesting. And then I want to step through and check those off and make sure that they're not bugs. Because if I'm going to spend the time to audit something, I don't want somebody, 2 weeks later to find something infinitely easier than what I was looking at. So you can do this process and give it to an intern and be like, listen, go do this for the week and come back, and then afterwards, when we've ironed out all the low-hanging stuff, we can actually go through and do a real audit. So the first part is an Python script. It looks for all the interesting locations of what I call peak points. So inline mem copies, string copy routines, calls to APIs that accept format string tokens, and it's actually smart enough to look to make sure that it accepts the %s. Calls to dangerous API like strcat and string copy, etc. And all these things are written out to a file, which I can show you. How are we doing on time? When do I have until? Until that sign language just stated. 25 minutes cool. I'll just skip this demo. All this will be available. I haven't uploaded it yet, but literally right after this talk, I'll upload it to OpenRCE, and you can go up there and pull down the thing. There's documentation for it all too, which I spent some time writing, more time than I should probably spend actually doing the slides. So you can go and try this for yourself. It'll generate a file. You then take that file, pass it to a PaiMei-based script, which is a little bit dated. The interface has changed a little bit, so there's cleaner ways of writing it. Attach to the process, and then every time one of those points is hit, it's going to prompt you, it's going to say, okay, here, at this potentially dangerous place was hit, here's the data that was hit at, what do you want to do? Do you want to skip it? Do you want to keep looking at it? Do you want to add a note? How do you want to handle it? It also supports automated keyword searching, like Pokeland or boron tagging. It can track WinSock calls to receive, which we'll talk about later, and since I don't have a good demo for this, we'll just move on. So the console, the overview of this console GUI. Some tools are too complex for command line. And the motivation behind the GUI really started when I was writing process Docker on this framework. 40 command line options into development. I'm like, I can't do this. I don't even remember these things. So you switch to this GUI style. So the development for this is well documented as well. You can create GUI modules really easily and take advantage of some of the built-in stuff of this overall console and take, put all your focus on actually the efforts on your tool, not efforts. So So I will just show this view of the launcher instead of going through that slide. So this is the GUI. It's not the greatest resolution for it, but this is what you got. So the general overview of it is it's like this notebook-style output. So every module has a little icon, and it's independent of the other modules, although you can talk between them. Anything in this right pane is controlled by the module. The status bar, this side of it is reserved for the console, and this side is reserved for the actual module itself. I haven't implemented a menu bar hook yet, but I will do that in the future. So under connections, these are like the console-wide options. So if I want to connect the entire console to my SQL server, or if I want to connect the entire console to UDraw, there's one more option. It's console PyDebug locale. This is actually, it's going to be useless for you because there's only local debugging supported. In our in-house version, PyDebug can work client-server, completely transparent of whether or not you are, like the script doesn't have to know. It's a one-line difference to make PyDebug work over sockets on a remote server or work locally. So those are the global options. So just for example, I'll connect to my SQL server running on my local host. It says in the status bar, successfully connected. The advanced menu, I can clear the log, so there wasn't anything in there right now, but there was 2 lines that dropped it. I can also toggle a Python shell. Now this thing is badass. This gives you, of course it's a Python shell, so you can do whatever you want, any Python statements. But you can also control the entire framework from here. So for example, I can do PaiMei.pstalker module, .basic block count, or whatever that, what is this? I don't remember what it's called. Yeah, .basic block count. And right now it's 0, which there are no basic blocks in here. I'll show you later how that thing will be updated. So you can grab any value you want, set any value you want. If you load a Pedram module, you can step through all the functions interactively, look for something, update things, and it allows you to do all sorts of advanced things. It's also self-documented. So on the right-hand side, every module has a little drop-down. This is the global. For the global, here's all your attributes, your current module, and it tells you what it is. It's a handle, it's a list of page, it's currently an activated module. It tells you, here is PyDebug. So if you want global handles PyDebug, this is how you do it. It's PaiMei.mainframe.pydebug. We go to pstalker. Here are the explicitly documented attributes. So the filter list, and all this will become obvious in the PETA module, the stock tag. And as you go through it, it's like self-documenting. It tells you all about it. Then there's just a help screen. I have all sorts of icons of this guy. I'm going to get stupid by putting Tarantino on my teammates help me. Other things about this, like you can make this full screen if you want. You can turn it back off. And there's a little hotkey for it. Let's switch back to the slides real quick. What do we have there? So we've gone through the general layout of documentation. So the most boring module is the documentation module. It's on an HTML viewer. You can step through and read about how it works, installation, scripts, blah, blah, blah. It also loads all the developer docs. So if I want to see, oh no. I might not have actually generated those docs. But I'll load up in the web browser so you can see at least. I haven't did my generate every docs. Now it should work. There we go. So this tells you all about PyDebug, every class, object, all the member variables, all the routines. So if you want to develop something, you can just come here, and it's really well documented. I spent, I think, a third of the 30,000 lines of code are comments. So it's really well documented to get support from people using it. And so there's PyDebug, PETA, utilities, pgraph, documentation for everything. The Explorer module is kind of like the hello world of the console, and it's very simple. So I will load a module, pull it up here, so I can just explore it. Again, this resolution is literal. So here's all the functions of this module, here's all the basic blocks. You pull up disassembly, all the basic blocks are broken out. And then if I connect to UDraw, which is over on, what is the name? I can graph any function I want. Does that work? Yeah, there we go. So now that function just grabs, again, over a socket, and like we can explore that function. So this is the control flow graph for that function. There's some other stuff that our in-house version of this does, but pretty much this is just there as a hello world for people to start playing with and use the model for development. So now, one of the more substantial tools is PaiMei File Plus, which Cody wrote, and Mike's going to want royalties on. Very similar to his tool. But he wrote it as kind of like a proof of concept to use the actual PyDebug, like exception detection capabilities. And it's very similar to Mike's tool. So it generates mutations, specified offset range, variable length, and byte values. It has some more advanced features that Mike's tool doesn't have, which does like additive mutations. So it'll read in, like if you give it plus 10 FF plus 10, it'll start going through reading 3 bytes at a time. It'll say, okay, add 10 to the first byte, make the second FF, make the third plus 10, and then keep doing that. It supports mid-session pause and resume, critical completion time, and one of the cool things he recently did, which I like, is he made this auto file discovery. So if let's say somebody just quit, you take their laptop, you put PaiMei on it, and you let it run through all the documents. And anytime it finds one, it looks at the auto handler through the registry. Then it starts buzzing it. So you can just install it, put it away for like 3 weeks, and come back a month later, see what happens and what kind of crashes it found. And the reason why that is cool is because many times file buzzing is dependent on what features are exposed in the actual document. So unless you have, whatever special table installed in your document, the bug may not manifest itself. And this kind of gives us a more brute force approach to seeing. So again, live. So here's the file buzz tool. Program name. What we're going to do. We'll do quick time. There. Source file, there's just a sample movie that comes with it, so I'll just use that. Destination directory is where it's going to generate all the mutated files. Next bytes. What else do I have? Start at 100, and then 50. Most good 8 seconds. Yep. And it generates files. So here's all the mutated files it generates. And one of the cool, oh no, the resolution breaks your beautiful hex inspector. So one of the cool things he wrote is like it actually shows you the modified byte. And this was a rudimentary change, but if you do a more advanced one, like it's beneficial to see the actual change byte. And the actual offsets are real. So if you can step through each one and see what the actual byte modification was. And then once you're good to go, which am I good to go if I hit run here? I can embarrass myself.
I think it should be good.
Cool. Where's that? Future of your employment depends on this down.
You're missing the pop.
Oh, actually it's on my side, that's why. I don't know if I can drag it over fast enough. There it is. But anyway, so it's going through file by file, telling you when it thinks it's going to be done. If there's any exceptions, it'll tell you about it over here. And we'll just step through, go through each one. So I'm just going to stop this. Come on now. Okay, just fine.
Can we see those movie files? Can you drag it up?
Can I what?
Can we see those movie files?
Well, it was popping up on the side, like it starts playing it, but then because there's a timeout of 8 seconds, after 8 seconds, if nothing happens, it'll just kill it. So that you don't just sit there and wait forever. It was popping up on my side of the monitor. And again, you can pull this down and try it yourself. So PaiMei did, this is a bin nipping tool being written by Peter Silverman. It's in early beta, so not being distributed, but it's a heuristic-based dipping engine like Sabre BinDip 1. The real difference between this and other dipping engines is the goal of the module is to allow deep control of the algorithm. And those algorithms can be saved for later use. So kind of like the theory is that you can create different job sets. So for malware analysis, this is the best algorithm to do dipping. For generic patch dipping, use this. For Microsoft patches, use whatever. And it supports all sorts of heuristics that you can customize. And some of these from Sabre, other ones are obvious, other ones can be made up. You can do API calls. So both function A and B call the same API, and they're the only ones that call that. Line them up. Argument and variable sizes. Look at the size of arguments and variables and stuff like that. Do 2 basic blocks reference the same constants. Use that as alignment. The control flow. If A and B are identical and they both call X and Y, then line those things up as well. CRC, which is actually useful for really small utility functions, which is one of the problems I find with BinDiff, is like the really small functions it's bad at matching those up, so that helps in those cases. Name, Negi is node edge call, and instruction count is graph heuristics. Recursive call, so if two functions are both recursive, they're the only ones, line them up. Or not if they're not the only ones. Even if there's 10 of them, like you can narrow down the range you want to compare against using that. Size, small prime product, which is a Sabre original. We support that too. There's Smart MD5, which is just an MD5 over all the opcodes. There's a stack frame comparison, string reference comparison. So there's all these different comparisons, and again, the demo. So this thing is absolutely hideous right now, but you can get like a general idea of what it's supposed to look like. Where did you go? So again, so here's the old version of PNG build with the new version. You can step through and see all the different attributes that he's calculated for these different things. And then the key to it is this configure option. So here's all the available heuristics. And I can control the ones and the order. So maybe I want to do 2 runs of SDP. Then I want you to do, graph heuristics. And I want you to look at the name, then Smart MD5, and the CRC, and the stack frame. Then I want you to do this 20 times in a row. And it'll do that. You can save it, and then execute it, and it'll give you the output, and they're like synchronized together. So these are all the lined up items that were detected as being the same. You'll see on one side I have symbols, on the other side I don't. And he hasn't implemented the actual ability to port the names yet, but it's just one step away. So you can kind of see as a brief intro to what he's trying to do on this visiting tool. All right, so then the big meat and potatoes of the console, the reason why I was motivated to write in the first place, is the code coverage tool, which is the next generation of process software. So one of the huge improvements is all the metadata that's stored in MySQL. So you no longer have to deal with all these files that are disorganized and hierarchy is going on. It's a 3-step approach. You set up data sources, capture coverage data, and then explore the captured data. And this force filtering will allow you to pinpoint interesting code locations. So this will be like the key portion of this demo. Sitting up in this. Everybody still hear me okay?
Mm-hmm. Yeah.
Great. So again, sticking with Minesweeper, just go here. I'm trying to connect to MySQL, and I'll just start from scratch. So this is a fresh, like when you first install this tool, this is what you're going to be looking at. We're going to right-click, add a new target. Call this Minesweeper that. Underneath that, you need to add tags, and a tag is essentially a recording from those of you who've used process software. It's just it's a way of tagging the code coverage I'm about to do. I'm going to tag, and it's going to be, I want to filter all the GUI stuff that I don't care about. I don't care about GUI handling code in Minesweeper. I want to locate the game logic, the actual lines of code that determine whether or not you won or lost. So first I'm going to filter out the GUIs and create a tag for that. We use the tag for stalking, add the modules that I want. Is that it? Yes, that's fine. Now I'm going to launch Minesweeper. There she is right there. I can either load the target, or in this case I'm just going to attach to it. Coverage depth is how you want to record it. Do you want to see all the functions that were executed, or do you want to go finer granularity and see all the basic blocks that were executed? We'll do basic blocks. Restore VP is whether or not you want to restore the breakpoints after they've been hit. If you're just interested in where you've been, you want to leave this off. If you want to know how you've gone, like the explicit paths that you've taken, you want to leave that on. But since we only want to filter out GUI code, we're just going to save that. Heavy is whether or not to store context data every time a breakpoint's hit. Again, we're just building a filter so we don't care about that. And this controls whether or not you're going to do unhandled exceptions, report on unhandled exceptions, or just handle exceptions. But we'll just leave it. It's fine. We're going to start stalking. So you see it's starting it. It's setting all the breakpoints from the main module. This main module is 183 functions, 683 functions. 683 basic blocks. It's telling you about all these DLLs that are loading, and it's good to go. So now as I interact with this thing, basic blocks are being hit. So I do like game new, game beginner, custom, screw around with this thing, turn this on and off. You can see in the background more and more code blocks being hit. And you saw in that case it required more modules to be hit. Anyway, and for a bit, we'll minimize it, maximize it, move it around. We don't want to hit any of these squares because that's going to trigger game logic, and I don't want to filter that out. And then we'll just close it so we can also get the basic blocks that are responsible for closing out the application. Again, we don't care about it. So it says there were 200 hits exported to MySQL. I load this up, and this is what I get. Here's all the different hits. It tells me my code coverage. Here's the number of functions I hit. Here's the number of basic blocks I hit. And for each one of these things, it tells me some context and reference data, which there are none because we didn't turn on heading. So this is our filter. So let's rerun Minesweeper. And we're going to create a new tag. Call this, whatever, game logic block. So this time I'm going to use this tag for stalking, and I'm going to filter out this other tag. So I'm not interested in any of the basic blocks or functions or whatever was recorded in this specific tag. And you can filter 20 tags if you want. There's no limit to that. You see that cute little scissor icon? Lets you know. We're done with filter. So again, refresh the process list, scroll down, go through mine. This time we actually do want to do context data since we might actually be analyzing what's going on with the game logic. So I turn that on, start stalking. You'll notice that there's no breakpoints being hit right now because I've already filtered all these out because I didn't care about them. So we'll go next. Good. So click on something. Now these 77 hits, I'm going to stop stalking. I'm going to load it up. These are actual game logic. We know that this code was responsible for figuring out that when I clicked on here, did I win or lose? So I've narrowed it down to the actual game logic. Now there's going to be some extra GUI code in here because, for example, the window message generated for clicking on a square, I probably didn't filter that out in this filter. So one feature that is existing, I will show it right now. We'll add another tag, game logic 2. Let's Minesweeper, launch again. In this first tag that we filtered all the GUI, we did it at the basic block level. But I'm just going to make the assumption that any function that I hit while processing GUI is going to just be doing GUI stuff. And it makes sense. It's rare that you have some code that deals with window messages and logic. So I'm going to say expand the tag. And what this is going to do is it's going to say, do you want to expand this out? I'm going to say yes, and it says okay. The tag expansion is complete. We added 89 new entries. So if we load this up, you'll see this TID is a thread ID. At the bottom, the ones that are 0 are the ones that were added. So what it did was it went through every function, and even if the basic block was not recorded and included in the tag, it went ahead and added it. And it got that information out of this PID line. So now we have a more comprehensive GUI filter. So we'll do it again. Filter this tag. Use this one for stalking. Did I restart this thing? I'm not sure. Launch Minesweeper. Refresh. All these options are fine. Start stalking again. Click on something. Stop stalking. So I have 59 hits from this one. And from this other one, I have 77 hits. So clearly we did a better job filtering here. And it's possible we have some false positives. We eliminated some things that we are interested in. For the most part, this is a good strategy for further eliminating GUI code that we're not interested in. So now for the really sexy part is, am I still connected to you, John? Okay. Just in case. Failed. I'm just restarting the run, making sure it's good again. Alright, now it's connected. So now for this game logic, I want to synchronize it with UDraw. So there it is. And again, resolution-wise, this is not the greatest, but so now as I click through here, I can go through the recorded data, see where I've gone. And it synchronizes them both ways, so I can move up, I can move down. And even cooler is I can click it here, or on this computer, and it'll synchronize on there. So right now we're highlighted on 9, but if I'm interested in this block's context data, it moves it over there, and so now I can see here's the value of all the registers at the time that that block was hit when I recorded it, however time ago. This is my dynamic real-time graphing, synchronization between the two. And again, it's like 20, 30 lines of code because it's all built into it. So final demo, I was actually curious about. I had heard that Minesweeper had a cheat in it. So I think this should be to redo this one. I'm going to redo the filter GUI, and it's going to erase all those currently hit ones. So let's restart Minesweeper. And this. All right, that should be enough. All right. So I'm just going to push a key, just push up or whatever, and there's some basic blocks that are hit. Stop stalking, synchronize that with draw. Load files needs to load up. There we go. And so immediately I saw this string over here. And so you can see the path that we took versus the path that we did not take. And I saw this string reference to XXZZY, and following that forward, that's the cheat code right there. If you hit XXZZY and enter, shift enter, it's done. The cheat's there. I don't know if you've ever seen the cheat, but it puts a little pixel in the top left-hand corner, lets you know when you're on top of the line now. So, again, using code coverage to be able to pinpoint exactly what you're looking for without having to do, low-level reverse, just playing around and pinpointing what you want. Just to run through the other options for this thing, if I want to load all the hits under this target just to see my total code coverage, for example, if I'm doing a cluster and I want to know, I ran, for example, Codenomicon's cluster of 45,000 test cases against some void box, and it only exercised 20% code coverage, that means nothing to me. Obviously, we have 80% left to still test. But if I ran a cluster and it covered 95% of my code coverage, and I know, okay, this was a pretty good test, it really exercised my entire program. So you can load all hits like that. Load hits replaces the screen. Append hits will add to it. So that just dropped it at the bottom. And then what else do we have? Tag filtering, target tag properties. You can add nodes, remove all those things. Oh, and then the final one is this export to IDA. So I'll show that right now. Is there any questions about this thing right now? No? Cool. So we do game logic 1 and game logic 2. I'm going to export them to IDA. So what this is going to do is, based on the color that I choose, we'll do something like, I want to color the basic blocks. I'm going to override any existing colors based off of this tag. So we'll save this as game logic 1. We'll do the same for this. Export to IDA, which is a different color. We'll do that. And this time I want to blend. So what's going to happen is, the first script when I run it, actually, let's just do that right now. Here's the line. Get this garbage out of here. I'm going to run that first generated IDC file. And it ran. Now we just need to go somewhere that it would have ran over. Like, that was right here. And you can see, and I'll switch this to graph view. You can see the areas, again, built into IDA using the grapher. We can see the actual code coverage that I took. So these are the blocks that are hit based off the color that I chose. So now I'm going to do the second one. And what I really want to know is, I want to know where both paths have been. So instead of overwriting, which will replace the color, or ignoring, which will leave the current color, I'm going to do blend. Which is going to, if there is an existing color, it's going to take it and blend it with the current one that I'm applying, so that you can see the paths that have overlap. And I'll do mark positions, which is going to generate item marks for each one of these hits. Adding context data as comments is going to put all this data at the top of each basic block. So if you want to look at the blue data interface, you can call this game launcher 2. Move on that script. So now we would love to find an area that was actually covered by both. Just choose one. Actually, we don't need luck, we can use them. That, there's only green in that one. Come on, keep two colors. Did I click blend?
Yeah.
So it's just a matter of finding one that has, both paths. One more shot. Is it just not? Well, no, it works. I promise. So it'll blend the two colors together, which, believe me, was actually not that easy to do. It took me some time to figure out how to write a decent blending routine to make the colors pretty together. So that's the final option for what you can do through this tool. Back to the slides. All right, some in-house tools and experiments that we have and been working on or abandoned, whatever, that aren't included in the utility. Time?
5 over.
5 minutes? 5 over? No, really? Hugo, you gonna strong arm me out of here? All right, I'll quickly run through this last one. So this proxy fuzz is kind of cool. Cody developed it. Simple concept for inline fuzzing. So here's like a typical client server, and I have to go through the slides because Eero made the graphics, and let them do it justice if we can. So the fuzzer sits in between it. Blue traffic is legitimate data. And what it'll do is, when it finds a packet that it thinks is interesting, it'll apply some rudimentary modifications to it. That's what this red thing is. And it'll attach to the server, which is receiving that packet with PaiMei, monitoring for exceptions. And the same thing happens in the other direction. So it'll just keep going back and forth and, arbitrarily changing like binary. There's some logic that we've added to it. And believe it or not, this is found bugs. We haven't spent enough time to actually make it smarter, but even if it's current state, it's found bugs in enterprise backup software you probably use today. So it's very easy like bug hunting. You just install client server, tell them both that the buzzer is a respective other party, let it run, and then find bugs on that. Hey, Hugo, ready?
Subscribe button in like 5 or 10 minutes.
Okay. Again, another idea was the socket stopper. So utilizing breakpoints and memory breakpoints, the idea of this was to track data flow access. So for example, let's say we have receive. We want to know anybody who touches the receive buffer. So we set a breakpoint on receive, and when that breakpoint is hit, we grab the second and third arguments, which is the buffer address and length respectively. If and only if the buffer's on the stack, I'll get into this in a second, we set a memory breakpoint in that buffer range. Then the memory breakpoint handler takes care of the rest. Anytime it's hit, there's a internal variable that says whether or not it's a direct hit, and we'll avoid the details of why that's an issue. And so it works. Like this is get functional data flow tracking. You can run this tool, and then any instruction which is going to touch that buffer is going to cause an access violation. We print it to disk. So with 40 lines, you can have this up and running. And again, the limitations because the memory breakpoint's smallest granularity is 4K, and so if you do this on the stack, you're obviously it's not even going to work. So the same thing we did for file swapping, and this is unbelievably useful for tracking down file format bugs. And I have to pull up this. So it's similar to the socket stopper, but one level extra of indirection. You need to create file. Look at the arguments. If the file name is something you want, save that handle as return. Same with map view of file. Use map view of file name, which you can call any arbitrary API you want from PaiDebug. See if it's the file name that you're interested in. For example, create time if it ends in .mov, save the file handle. Later, when there's a read file or read file EX, if it's from a handle that we're tracking, track the buffer in the same way that you do it with the socket stopper. Like here's like an example output. And it's actually from QuickTime. So this was a blurb that was read using read file, and every byte was tracked, and the bytes that were touched are highlighted, and this is HTML. So I know that this byte was read from by this address, written to by this address. And for any other chunk that was read and operated on, same thing. Like you can see like there's some parser here, it's going through and looking for whatever it is that it wants. So again, wherever you have a byte, see who's touching. So the whole dealing with memory breakpoints being too large for stack, for a file, you can actually deal with this. Let's say we have a stack buffer, it's broken up into whatever you want to say, byte, word, keyword, 4x3, 12 segments. What we can do is use parallel and serial hardware breakpoints. So we have an arbitration script, and let's say you have 5 virtual machines. We'll divide the target buffer among the available systems. So virtual machine 1, you look at the first segment. Virtual machine 2, you track the second. And this is all with hardware breakpoints, which is much more granular. So we do the same thing. Once it's gone through, we have to cover the whole file, so we can restart the process with the same target file and do it again. This time the arbiter says, look at the next slice. And this is possible with files because processing is deterministic. And we have 3 ways of restarting. We can revert the snapshot, we can restart the process, or we can try and use the memory snapshot restore capability of PaiMei. So again, to repeat the third time, it's just going to require 1 and 2. And then in the end, which I already showed you the output, you're going to have the capability of tracking stack buffers as well. So like something like this, if you were going to build this in C, it would take you a month to do it. It took like a weekend to do it on top of Python because it's just so much easier. You just focus on the logic of the tool, not the actual development. All right, finally, my attempts to inspire. I'll put the slides up so you guys can see it, but just some ideas I've had for people to kind of give feedback and to build tools on top of it. So it's a malware profile, you can read about it. Adding symbol support to PyDebug, making Explorer interface more advanced, yada yada yada. A real installer is going to be key. Installation is not the easiest thing to do with PStalker. I have a script that will make it fairly easy, but in order for this to spread to the masses, somebody's got to create a point and click nullsoft installer. And we'll just wrap it up there. Is there any questions about the framework? Anything? Yes?
So you said your hardware breakpoints have a 4K granularity?
No, memory breakpoints have 4K granularity.
Yes. So when you hit that, you get the instruction that hit that.
Yeah, so when a memory breakpoint is hit, it'll say, here's the instruction that hit it, and then it'll tell you whether or not it hit on your buffer. So let's say I have a buffer that spans 2 pages. Here's a page, here's a page. My buffer's in the middle. PyDebug has an internal flag. It'll say, was that access violation, the actual touching of it, was it within that range? And if it was, you can know whether it was a read or write, what the address in the buffer was, and what the instruction was.
So if you can tell the actual address, then why do you need to do the multiple virtual machines?
Because if you try and set a 4K breakpoint on the stack, your program's going to come to a grinding halt. Every stack operation is going to trigger that memory breakpoint. It's going to go through the debugger, through all that context switching, and then it's going to say this was not in your correct one, because 4K is huge in the stack, so it's unusable. So you can really memory breakpoints are for heap only.
Okay.
Yes.
The crash synopsis, you found using it for kernel dumps?
For what?
Kernel dumps?
For kernel dumps? No, it doesn't. It doesn't take a crash and read what it's done. When you're attached to a process and a crash occurs, it collects live data. So here's the status of all the registers. If this register pointed to a string, tell me about it. Here's your disassembly around, stack unwinding, SEH unwinding. So it's when a crash occurs in the debugger, if you're sitting there looking at it, I try and capture as much of that data as possible and store it for you. Any other questions? No? Sorry about running over. That's the downfall of writing the slides 10 minutes before the talk. Thank you.